mentioned a couple of videos ago that we're going to have to take a look at negative infinity separately, and here's what we're going to do. Because raising any value to an even power produces a positive value, but raising a negative value to an odd power produces a negative value, we don't have a catch-all rule for approaching negative infinity. We have to look at it on a case-by-case basis. So I'm going to walk you through a few examples here. I think this will make more sense. So for number one, we can see that we've got the higher power in the denominator. This is a 5, and this is effectively a power of 1. Now, in this particular case, we're going to still approach 0. Whether we approach it from this side or from the bottom, that doesn't actually matter. So when we have the power larger in the denominator, that's still 0. There's no such thing as negative 0, so it doesn't actually matter whether it's positive or negative infinity in this particular case. In the second case, this is where it gets a little more interesting. Now we've got 2x cubed over 5x squared. And I realize that we could just simplify this to 2x over 5. We'll discuss that in a moment. But the logic would apply the same if I had something like this, where we couldn't reduce it, because we would still only consider the first two. So let's just take a look at it from the perspective of just looking at the 2x cubed over 5x squared, neglecting that we can simplify it. This is more of a thought exercise than anything. So the power is higher in the numerator, so we know we're going to infinity. However, is it positive infinity or is it negative infinity? Because both the coefficients are positive, we don't have to worry about the negation occurring there. But if we're going toward negative infinity, this is a negative value that's going to get cubed, which is negative. In the denominator, though, we're going to have a negative value getting squared, which is positive. So that means that the numerator will be negative, the denominator will be positive, and that means we're not going to infinity, but we are rather going to negative infinity. And let's take a look at case number 3, where we have a familiar situation where we have a square root here. So no, this is not going to 0, because the denominator power appears to be larger, but it actually isn't. So let's reduce this to just 15x over rad x squared. Now we're going to get 15x over x. And sure, that appears to just be 15. But remember, when we square something, we're going to get a positive value. And then when we square root that, the square root of a number is always going to be positive. When we square root 9, we are only considering the positive 3. If I want negative 3, I have to write negative square root of 9. So that means that this denominator is going to be positive, but the numerator, because I'm just putting in the negative value into the x, is going to be decidedly negative, which means that this answer isn't 15, it's negative 15. So be particularly mindful of negative signs and odd powers. Also, be mindful of limits as we approach negative infinity rather than positive infinity. They're not likely to change the value, but they will change the sign.